This is for those of you that are working on your data analysis for your tigers and having a hard time because you're trying to look at the relationship between two quantitative variables. So for example, if you're looking at age and length, or age and weight, or weight and nose black, any of those where you're looking at two quantitative variables at the same time. I've gotten several questions about this because you get lots of data that's hard to interpret. So I'm going to go through one and just show you what I would do with this. That might make it easier for you. So what I'm going to look at here is the relationship between age and length. And I've got some data that I collected on the tigers a while back. If I want to look at the relationship between age and length, the first thing I would do is try to do some summary stats. And I'm just going to show you what might happen if you're doing this, and this is the problem that several of you have already run into. So let's say that I look at length and I try to group it by age. When I click on compute at the bottom, it tells me there are lots of unique values for age, and it asks me if I want to turn on binning. What this means is that it wants to create age classes because otherwise it's got too many different age values. If you look at all the different ages over here, since they're in decimals, there would be lots and lots of them. And you don't want to have summary statistics for each different possible value of the age. So I'm going to tell it OK so that it does turn on binning. When I do that, what it's going to give me is the summary statistics for each different class that it came up with. It's going to decide what classes to use for the ages. They aren't necessarily what you would want, but there's no way that I know of to change this particular thing in StatCrunch. If it turns on the binning, then it decides how to bin them and you can't change it. So what this gives you is the statistics for the different age classes for their length. This might be something that's helpful, but sometimes it isn't. For this one, you would just have to look at it and see if maybe it's telling you anything important. The only thing that you could maybe tell in this is that it looks like as the age classes go up, the mean length is going up a little bit. The other thing that I would see looking at this is that the standard deviation for the youngest age class is really big compared to the other ones. That would tell me that in that age class there's a whole lot of variation. That kind of makes sense because this would include the cubs, the really young ones, and you would expect that their length would be a lot shorter than the rest of them. And if we look at, say, the min and the max for this compared to the other ones, the max is about the same as the rest of these, but the min is much shorter than these other age classes. So really this isn't giving us a whole lot of helpful information, except that maybe this is including cubs that are a lot shorter. But as far as the rest of them, it's not really telling us a whole lot about the relationship between the age and the length. So I'm going to keep this one over there, and then I'm going to try and do some frequency distributions. This is another place where sometimes you can just get way too much information and it's hard to interpret. So again, on this one, I'm going to put in length here, and I'm going to ask it to group by age. It's going to ask me the same thing. It wants to turn on binning. Here's what happens if I do that. It's dividing it up into these different classes, and so I've got all these numbers in here. I've got 4 different frequency tables. Again, this isn't necessarily all that helpful. If I look at the youngest age group, I can see that there are some shorter lengths in here compared to the other ones, because this is the only one that has any between 40 and 50, or between any that are 50 and 60. The other ones all start at 60 and go up. Other than that, I'm not necessarily seeing a lot here that's helpful. The only thing I could notice is in each one of these, it looks like the 70 to 80 length has the highest frequency. That's happening in every one of these. But this is another one that whether this is very helpful is kind of questionable. So I'm going to put this one over here too. I'm going to try and do something else. So next I'm going to look at a histogram. Same thing, I'm going to do length and group by age. It's going to ask me to turn on binning. So this time what it's giving me is 4 different histograms. So this is for the youngest tigers, This is for age 5 to 10, this is age 10 to 15, and this is age 15 to 20. Even if I separated all these and looked at them side by side, I don't know that that would tell me a whole lot right there. So I'm going to put this one over here too. What I'm trying to show you with this is that you can get a whole lot of information that's not very helpful. You want to keep trying things until you do find something that maybe is telling you something about the relationship between the two. So now I'm doing box plots. For this one, this is maybe a little bit more helpful because at least it shows you the box plots side by side. What we can see with this one is that, yeah, for the 0 to 5 age group, there's a lot more down here at this lower length. And for the other ones, there's not a whole lot of difference between them. And even for this first one, we've got actually some longer tigers in this one. This is at least showing us something where we can maybe see the relationship. For some of these, what your answer is going to be for your question is that there doesn't really seem to be much relationship. That's kind of what I would say with this. It doesn't seem to make much difference in their length, depending on how old they are, except for the very young tigers. So before they're full grown, yes, their length is probably shorter. After that, there doesn't seem to be much relationship. And sometimes that's the answer you're going to come up with when you're looking at things like this. That's okay if you come up with an answer of, no, there really isn't a relationship. So this graph is maybe a little bit more helpful than some of those other ones. Now, the other thing that I really do want to look at if I'm looking at the relationship between two quantitative variables, one that is probably going to be helpful is going to be a scatter plot. And in this, it really doesn't matter which one I choose for X and which one I choose for Y. And for this, I just want to do a basic scatter plot. I don't want to do any binning, and it shouldn't ask me to. This is a scatter plot. What this does is that for every row in my data, it's putting together an age and a length, and then it's using that to plot a point. So here's one point. This is one tiger that had a length of 78 and its age was 10.9. So that's actually the point. The X value for this point is the 10.9 and the Y value is the 78. What this is showing me is, again, that there's not really much relationship. I can see my younger and shorter tigers over here, but after that, it looks like after they get to a certain age, the lengths are all kind of in the same range. It doesn't make much difference how old they are. So this would show me that there's really not much relationship between the age and the length. Now, for some of the other ones that some of you are doing, where you're comparing two other different quantitative variables, you might see that there does look like there's a relationship. In your scatter plot, if you've got your points mostly going up as they go to the right, then that tells you there is a relationship between the two. Or if you've got something where your points are kind of in a general pattern of going down as they go to the right, then yeah, that tells you that there is a relationship. But a scatter plot is a really good thing to do if you're trying to compare two quantitative variables and see if there's a relationship between them. So that's a graph I would definitely include in your 3 graphs if you're looking at this kind of question. The other thing that I've suggested to several of you if you're trying to look at the relationship between two quantitative variables is just to look at things for each variable separately. So in this case, I might, for instance, do the summary stats for the age and the length separately. So not grouping by one thing or the other. I'm just going to look at age and I'm going to look at length. This at least gives me an idea of what's happening with each of the two variables. So this one, I can see that average age is about 7.5. I've got a fairly big range of ages. This goes from 0.6, which would be those cubs, up to 18.6, which is a pretty old tiger. And then for the lengths, I can see kind of what the center of the lengths is. The mean is about 71 and the median 72. I can see my minimum length is 46, my maximum is 85. From this, I can probably make an assumption that these younger tigers are the ones with the shorter lengths. And that's again something I could tie back to my scatter plot. When I see these points over here, those would be the ones that are coming out in this minimum age and minimum length. So that's a really good thing to do. I could also look at things like histograms for each variable separately. So I could create one histogram for the age and one for the length. And again, I'm not grouping by anything here. So there's one for the ages. One thing that this tells me, this is going to break my ages down into some different classes. And for the histogram, I can control what these classes look like. This one is breaking it down into classes of width 2.5. So this first one is going from 0 up to 2.4, and then 2.5 up to 4.9, and then 5, and so on. I can see how many of the really young tigers there are this way. And if I wanted to break it down even more, if I wanted to make that go from just 0 to 2, I could tell this to start my bins at 0 and make them width 2. So now I can really see how my ages break down. So these are the ones that are between 0 and 2. These are the ones that are between 2 and 4. I can see how many of those really young tigers I have this way. Then I would do another one where I'm just looking at the lengths. And with this, I can really see what's happening with the lengths. I can see that most of them are here between 65 and 80. I can see that there's some shorter ones over here, and I could kind of make the assumption that those are tied to these younger tigers over here, especially if I'm looking at this along with that scatter plot. I could also do this with the box plots. And for this, if I'm doing a box plot for two completely different variables, then I just want to do each one separately. So I could do a box plot for the age. There it shows me some basic information about my ages, and then I could also do one for the lengths. I can look at this, and since I do the box plot so it shows me outliers, I can see that I've got these outliers, and those would be the young short tigers. So again, I can kind of tie this to what I've seen in the other graphs, and I can assume that these shorter lengths have to do with my younger tigers. But after that, I've got a bunch of lengths here that are between 68 and 77. That's where this box is, between the Q1 and the Q3. And I can also see on the ages that I've got a lot of ages between about 4 and about 11. So that's my advice for what to do with the graphs and everything when you're trying to look at the relationship between two quantitative variables. If you just get way too much information, like on some of these graphs that we had back here, it really isn't necessarily even helpful. But if you have other questions about these, please just ask me. I know some of you have already asked, and I've tried to answer your questions, but I'm still working on that.